So, hello everyone. Welcome to the course on earthquake seismology. I hope you have been having a good time in attending this course. And so far, I did not receive any query. So, what I am going to do today is to start with assignment one, and I will go to some of the questions one by one, and we'll see if there is any questions that is need to be given any explanation for. So if you look at the screen, I have just opened my assignment one. So let's go to the question number one. It is asking for the point where the earthquake rupture starts is called epicenter, hypocenter, center of the earth, and the Benny of zone. So earthquake rupture start at the location where the earthquake nucleates. So this is the position where the hypocenter is located or the focus of the earthquake is located. And the epicenter is the point just directly above at the surface of the hypocenter. So the question answer is B, the option B, hypocenter is correct. And the question number two, which of the following is the discontinuity between Earth's crust and mantle? Four options are given. Morovisic discontinuity. So this is the discontinuity in between crust and mantle. So this is the correct option. And the option B is Gutenberg discontinuity. And this is the discontinuity in between mantle and the outer core. And the third one is Conlet discontinuity, and this discontinuity lies within the crust between upper crust and the lower crust. And the last one is Lehman-Bullen discontinuity. So this is the discontinuity lies in between outer core and the inner core. So the option A is correct. Question number three, which of the following function may be the solution of the wave equation? So if you remember in my lecture one of module one, I have explained about the wave equation for a wave traveling in the string. And for the wave traveling in the string, and we also found the solution for that wave equation. And the solution should be in the form as a function of x plus minus vt. So any linear combination of x plus minus vt should be the solution of the wave equation. So if you look at option number A, sine in bracket x plus vt square. So you can see x plus vt square. It is not a linear combination of x plus minus vt. So you can say that the option A is not correct, and option B, cos 2x plus vt square. So this is also not a linear combination of x plus minus vt. So option B is also incorrect. Option number D, x. Option number C, sine x plus vt into sine x minus vt. So it is a multiplication. So it is also not a right choice. And the option D is x plus vt whole cube. So this is the linear combination. So you can say this is the answer. So for question number three, the answer D is correct. For question number four, for the given stress tensor for elastic and isotropic medium. So this is the stress tensor, and we know that stress tensor in elastic and isotropic medium is symmetric in nature. Given that the element opposed to the diagonal will be similar, that means they will be same. So 1 will be equal to capital B and minus 2 will be equal to capital A. So if you look at the options, then A is equal to 1. That is not correct. A is equal to minus 2 and B is equal to 1. that option seems correct. So option B is correct. So you know that in this assignment, only single answers are correct. So option B is correct. B for Bombay. Let's go and talk about the question number 5. For the given stress tensor whose elements are in kilobar. So you can see this is the stress tensor given, and also they are asking which of the following option is are correct. And given is crustal density 2.7 gram per centimeter cube. So for the for that so if you look at this option A, minus 1.5, minus 1.55, and minus 1.45 are the principal stresses. So you know, when we rotate a stress tensor in such a coordinate system where all the shear stresses should be zero, then the element along the diagonal are the principal stresses. But in the current form, the stress tensor is not along that coordinate system because the shear stresses are not zero. So the element along the diagonal are the normal stresses, not the principal stresses. Option B, minus 2, 1, and 3 kilobar are the shear stresses. So if you look at the minus 2 is there, 1 is also there, and 3 is also there. So this option is correct. So this is the right answer. And C option is mean stress is minus 1.47 kilobar. So mean stress is just simple. Take the sum of the diagonal element, that you also call it the sum of the diagonal element of a stress tensor is also known as trace of a tensor, trace of a stress tensor. So you can sum them up, take the average, which should come out to be around 1.5. So the option C is not correct. This lithostatic pressure correspond to the depth of 7 kilometer. So it is also simple. Pressure is equal to density multiplied to acceleration due to gravity and height. So formula is rho GH, and the crustal density is given 2.7 gram per centimeter cube. You can convert to gram per centimeter, kilogram per centimeter per meter cube, per kilometer cube. You can calculate it, and then G is acceleration due to gravity. That we know the value of it, 9.8 meter per second square, and H that you need to find out. So so what you are basically going to do is, uh, let me share another screen where we will solve it. PS1, yes. So I hope the screen is visible to you. And for the last option, what I am saying is you are required to calculate lithostatic pressure. So lithostatic pressure is lithostatic pressure that is equal to basically mean stress, and that is further equal to rho GH. So rho that is given, that is equal to 2.7 gram per centimeter cube, and when you will convert it into kilogram per meter cube, then it will come out to be 2700 kilogram per meter cube. And G is the acceleration due to gravity, which is 9.8 meter per second square, and H you are required to calculate. So we know that 1 kilobar is equal to 10 to the power 5 Pascal. And when you will solve this, like lithostatic pressure, that is 1.5, that is the mean stress that they have asked you. Rho is 2700, and G you need to calculate in terms of uh, uh, kilometer per second square. So meter to kilometer 1000 maybe, and when you will multiply it to the h, so this you are required to find out. When you will do your calculation, it will come out to be 5.6 kilometer approx. So if you look at uh, our answers, then this one. So when you will look at our answers, let me reshare it again. Um, yes. So if you look at the answer D saying that the mean stress corresponds to the depth of 7 kilometers. But our calculation says it should be at a depth of 5.6 kilometers. So option D is incorrect. So only option that is correct is option number B. Question number 6. A 1 hertz P wave produces a peak displacement of 17 micrometer. The amplitude peak acceleration at that point will be, so the maximum acceleration or the peak acceleration will be at omega square a. So given that, so when you will incorporate all those values, because omega is equal to 2 pi f, and acceleration you are required to calculate, and peak displacement is given. So when you will calculate, like acceleration is equal to omega square a, so a you are required to acceleration you are required to calculate, so omega square multiplied 17 micrometer. So the answer should come out to be around 671 micrometer per second square. For the following stress tensor whose elements are in kilobar, so for this purpose, you are required to solve the eigenvalues. So basically, you need to take the determinant. So for this purpose, you should you should be able to solve it basically in this manner. So basically, you are solving the determinant 2 minus lambda minus 5 minus 4, and then minus 5, 3 minus lambda minus 5 minus 4 minus 5, and 2 minus lambda, that is equal to 0. So it will be a cubic order equation. And then when you will solve this determinant and solve the cubic order equation, then your lambda should represent the principal stresses, and that will be 8 minus 7 and 6 kilobars. So the answer should be option your option should be 8 minus 7 and 6. Option number A should be correct. Likewise, the given strain tensor, assume Lami's constant are 1 unit. So for this question, strain tensor is symmetric in isotropic medium. So this tensor corresponds to the strain in isotropic medium, because if you look at the symmetry along the diagonal element of this strain tensor, all are symmetric. So this is in the isotropic medium. So question number A8, the option A is correct. Question number 9, you are given with lambda and mu that are 1 and 3 unit respectively, and which of the following option are correct. So you need to calculate bulk modulus. So bulk modulus K, if you can recall the formula, then K is equal to lambda plus 2 by 3 mu. So you can easily calculate that. Likewise, shear modulus mu uh, that is 3 unit. So option B is incorrect. Poisson's ratio is lambda by 2 in bracket lambda plus mu. So that should come out to be 0.125. So option C is also incorrect. And option D, Young's modulus, that you can easily solve it for. That is mu in bracket 3 lambda plus 2 mu divided by lambda plus mu. That should come out to be 6.75. So option A is correct. So question number 10. In the question number 10, it says if the acoustic impedance of the second medium I2 is less than the acoustic impedance of the first medium I1, which of the following option will be certain true for the normal incidence? So for the question number 10, so amplitude of the wave will be preserved. Uh, that is not necessarily be true. If you remember, we did talk about the energy flux. So energy flux, uh, so energy per unit, uh, so energy per unit wave velocity should be conserved. So energy flux remains conserved. So first option is incorrect. Transmitted wave will bend away from the normal. For the normal incidence, it is not true. And answer number C, option C, energy of the incident wave will not be preserved. So this is also not true. Energy will remain preserved. Reflected wave will arrive with a phase shift of 180 degree. So option D is correct. So what happens in acoustic impedance of second medium is lesser than the acoustic impedance of the first medium. So the reflection coefficient will be negative. So that means there will be a phase shift of 180 degree uh, in the reflected wave. So option D is correct. For the sandstone, the average density, Lami's constant, and BP are given. Then you need to calculate shear wave velocity. So for that purpose, alpha is given, that is 5.7 kilometer per second. That is equal to under root lambda plus 2 mu by rho. And when you will solve it, then you will get mu, that is basically around 24.86 gigapascal. And then you can use the formula for shear wave velocity, that is under root mu by rho, to calculate the shear wave velocity. Now, since we have solved the assignment 1, let's talk about the assignment 2. The assignment 2, let me share it. Yes. So in assignment 2, there are questions. I am not going to solve all the questions due to the constraints on the time. But question number 1, we can solve. Uh, so the question number 1 says the velocity of the P wave increases linearly as a function of depth in the functional form V is equal to V naught plus Bz. Here, Z is the depth and B is equal to zero point 0.5 per second. V naught 3.4 kilometer per second. Time taken by the normally incident P wave originates from the surface to reflect from an interface present at a depth of 5 kilometer is. So I think this is a simple question, but let's solve this one. For solving, yes. So So basically, the time taken by, so t you can calculate as an integral of dt, and that is basically because you are going from a depth of 0 to 5, so it will be dz divided by the velocity, that is the function of z, something like this, bz, and that is when you will calculate it, it will come out to be 1 by b in uh, in bracket ln v naught plus bz, that will be 0 to 5. So when you will solve it after putting their limits, uh, then this t should come out to be around 1.1 second. So we have done nothing, just we have taken the time formula, that is depth divided by velocity. So dz divided by v naught plus bz, so 0 to 5, and then we solve the limits. So it will come out to be 1.5. So it is a normal incident, and so the wave is going from the surface. Let's suppose this is your surface, and the interface is at a depth of uh, 5 kilometer. So ray is going down. So time taken by the ray is 1.1 second for going down, and the similar time it will take when it is coming up like this. So the total time will be twice of what we got. So the total time will be equal to 2.2 seconds. Likewise, we can solve the question. So question number 2 is very simple. The numbers are given just to confuse you, but now you can see if you look at the options, it says direction of wave vector will be same as the direction of wave propagation. So wave vector, wave number vector, and the slowness vector all have the same direction. So option A is correct. Option B, slowness vector will be orthogonal to the direction of the wave propagation. This is not correct. Wave vector will be orthogonal to the direction of wave propagation. That is also not correct. Slowness vector will be direction opposite to the wave propagation. That is also not correct. Question number 3, the ratio of the square of p wave velocity, s wave velocity for the Poisson solid. So for the Poisson solid, ratio is under root 3, but they are asking for a square. So option D should be correct. That is equal to 3. The question 4 is simple. I am not going to solve this question. So question number 5. The equation for the displacement of 1 Hertz P wave propagating in plus x direction at 8 kilometer per second. So like you can just apply the equation of wave u x t is equal to a e to the power iota omega t minus k x, and omega we know 2 pi f, so it will be 2 pi into 1, that is 2 pi, and k you can find out omega by v. So omega you have find out, that is 2 pi, and v is given, that is 8. So the k vector will be pi by 4. So the answer will be ux comma t will be equal to a e to the power minus 2 iota pi in bracket t minus x by 8. So option A is correct. Question number, you can solve uh, question number 7. Let's take this one. Two waves of the same amplitude of frequencies 4 hertz and 2 hertz respectively, the ratio of total energy. So amplitudes are same. The ratio of energy will be square of the ratio of the square of the frequencies. So you just need to take the ratio of the frequency, then square them up. So it will be 4 square divided by 2 square, that will be equal to 4. So answer should be 4. And question number 9, they are asking for the magnitude of the display. The P wave potential field is given by this particular function, 3x square yt plus y cube z. The magnitude of displacement of the P wave at point this at t is equal to second, t is equal to 6 second is. So the potential field is given, that means phi is given. So let's solve this question. Uh, so the question number, this is the question number 9 of assignment 2. So P wave potential field is given, that is given, and that is basically represented by phi, and that is 3x square yt plus y cube z. And if you want to find out particle displacement of this P wave, then you can just calculate the particle displacement u in subscript p, that is the gradient of phi. And for solving this, so gradient is what? I cap del by del x plus j cap del by del y plus k cap del by del z. And that will be for phi 3x square yt plus y cube z. So now when you will solve this, you will get 3xy, 6xy t iota cap plus in bracket 3x square t plus 3 by square z j cap plus y cube k cap. And in this you can put x comma y comma z, that is equal to -2 comma 3 and 7, and time is 6 seconds. Then you will get modulus of up, magnitude of up, that will be almost equal to 340 unit. So when you look at your options, I'm sorry, I have to go ahead, back and forth. So when you look at your options, then you can see the option B for Bombay is correct. The discontinuity of, so this is, I think it's a very simple question. The discontinuity action vector across the interface will lead to blowout of the. So for this question number 10, the option D, displacement, is correct. For question number 11, for question number 11, it says for a medium composed of upper, middle, and lower layers with velocity 6, 8, and 10 km per second, calculate the angle of incidence in the 8 and 10 km per second layers for a ray with an incidence angle of 10 degree in 6 km per second layer. What is the smallest angle of incidence in the 6 km per second layer? That causes total internal reflection at 8 km and 10 km interface. So total, we know that in the total internal reflection, the angle of reflection is 90 degree. So for that purpose, you need to find out the smallest angle. That is, so basically what we are doing is, so what we are doing is, so there is, so question number 12. Okay, so there is this surface and the velocity v1 is given, that is 6, and there is a ray that is incidenting upon this interface and making an angle j1, let's suppose. And after refraction, this ray is moving downward and making angle j2 on the second interface. So there the velocity is 8 kilometer per second, and there is another interface, uh, or you can say maybe the half space, v3 is equal to 10 kilometer per second, and this angle that it is making is j3, sorry, j3. Okay, so so what we are given with, we are given with j1 is equal to 10 degree, and we know from Snell's law, uh, sine of j1 divided by the corresponding layer's velocity v1 is equal to sine of j2 divided by v2. So when we put the velocities v1 and v2, and we know j1 10 degree, then you can easily find out j2. So j2, as I calculated, was 13.4 degrees. So there is a total internal reflection. So j3 is going to be 90 degree, and j2 must be greater than the critical angle. So critical angle is the minimum angle at which the 90-degree refraction happens. So in that case, you need to find out the smallest angle. So sine of j2 divided by uh, corresponding velocity 8 is equal to sine of 90-degree divided by 10, and that will give you j2, that is sine inverse 8 divided by 10, and that will come out to be 53.13 degrees. Now you need to find out the smallest angle in the 6 kilometer per second layer. So now the smallest incident angle in the 6 kilometer per second layer is sine of j1 divided by 6, that is equal to sine 53.13 divided by 8. So that will give you j1 as 36.9 degrees. So this is the smallest angle. When we look at our options, then which option is correct? So 36.9. So option D, D for door. So option D is correct. So today we are going to solve these two assignments, and for the next three assignments, we will meet in the live lecture 2. And so this is all for today. So thank you so much, and bye bye.